quadrilateral ABCD has right angles at B and C, ABC is similar to BCD, and AB is greater than BC. There is a point E in the interior of ABCD such that ABC is similar to CEB, and the area of AED is 17 times the area of CEB. What is AB over BC? First, we direct our attention to quadrilateral ABCD, which has right angles at B and C. Note that we're given ABC is similar to BCD, so we have AB over BC equals BC over CD. Since this is just a ratio problem, we're given nothing other than pure ratios in the problem, such as the area of AED over the area of CEB is 17, and we're asked for the ratio AB over BC. We can simply assume that BC is equal to 1. So AB times CD would be equal to BC squared, which would then be equal to 1. So we can let AB equal x and CD equal 1 over x when BC is equal to 1. Now we can direct our attention to point E. Note that ABC is similar to CEB, therefore angle ABC, which is 90 degrees, is also equal to angle CEB. So we can say that CEB is a right angle, like ABC and BCD. We also know that CE over EB, because of similar triangles, it's equal to AB over BC, which is just x. And also CE squared plus EB squared is equal to 1. CE squared over EB squared is equal to x squared, because CE over EB is x. So we can do EB squared plus x squared times EB squared is 1. So that means EB squared times 1 plus x squared is 1, which means EB squared is 1 over x squared plus 1. In turn, this means that CE squared is equal to x squared over x squared plus 1. So we can find the area of triangle CEB by multiplying these two numbers we found for EB and CE by square rooting EB squared and CE squared, respectively. If we multiply them and divide them by 2, that's the area of triangle CEB, because it's a right triangle and these are the two legs. So the area of triangle CEB is equal to x over 2 times x squared plus 1. Now we are going to express the area of triangle AED in two different ways. For one, it's just 17 times the area of triangle CEB. So that would be 17x over 2 times x squared plus 1. AED can also be expressed as the area of ABCD minus the area of CEB, and then minus the area of ABE, and minus the area of CED. If we can find the value of this expression and set it equal to 17x over 2 times x squared plus 1, then we can write an equation in terms of x, which can allow us to find the value of x, which is what the problem asks us to do. So first, let's find the area of trapezoid ABCD. This is a right trapezoid with bases x and 1 over x and height 1. The area of the trapezoid is the average of the bases times the height. That's x plus 1 over x times 1 over 2. Or more simply, if you multiply both numerator and denominator by x, you get x squared plus 1 over 2x. Secondly, the area of CEB. The area of CEB is what we already found up here. And that's x over 2 times x squared plus 1. For the areas of triangles AEB and CED, we need to make use of the altitudes drawn from E to AB and E to CD, which I've already drawn in green. And I will call the foot of those altitudes F up on AB and G down on CD, respectively. All that's left is to find EF times x over 2 and EG times 1 over 2x. We need to find EF and EG, but know that those altitudes have actually given us more similar triangles. The first one is EFB and BEC. Note that triangle EFB is similar to triangle BEC because angle EFB equals angle BEC equals 90 degrees. That's obvious, they're both right angles. But also, by alternate interior angles, we have angle CBE is equal to angle BEF. because BC is parallel to FE. So the two triangles are actually similar because these two angles are equal in them. So we can write triangle EFB is similar to triangle BEC. And therefore EF over EB equals BE over BC. So we can write EF times BC. BC is 1, so we don't need to write that. EF equals EB squared. EF equals EB squared, and EB is 1 over the square root of x squared plus 1. So EB squared would be 1 over x squared plus 1. So EF is 1 over x squared plus 1, and the area of triangle AEB is EF times x over 2. So we have the area of triangle AEB equals x over 2 times x squared plus 1. Finally, the area of triangle CED, which is EG times 1 over 2x. We also have a similar triangle with EG in it, and that is triangle EGC is similar to triangle CEB. Why? Because first, angle EGC is equal to angle CEB. Those are both right angles, obviously. And second, by alternate interior angles, we have angle BCE equals angle CEG. And that's because BC is parallel to EG. So these two angles are equal, meaning the triangles are similar. We can do EG over EC equals CE over CB. So EG times CB, we don't need to write CB because it's equal to 1, equals CE squared. And CE is x over the square root of x squared plus 1. So that means EG is just x squared over x squared plus 1. The area of triangle CED is this times 1 over 2x. So the area of triangle CED is this times 1 over 2x. That's just x over 2 times x squared plus 1. Now we have found two different expressions for the area of triangle AED. Let's now attempt to set them equal. So the first one was 17x over 2 times x squared plus 1. The second expression was x squared plus 1 over 2x minus 3 times x over 2 times x squared plus 1. Surprisingly, all three triangles have the same area, and that's x over 2 times x squared plus 1. Now we add 3x over 2 times x squared plus 1 to both sides. We have 20x over 2 times x squared plus 1. 20 over 2 is 10. So 10x over x squared plus 1 equals x squared plus 1 over 2x. 20x squared equals x to the 4th plus 2x squared plus 1. And now we subtract 20x squared from both sides. We get x to the 4th minus 18x squared plus 1 equals 0. This is a quadratic in x squared, and we can solve it pretty easily. We have 18 plus or minus the square root of 18 squared, 324, minus 4 times 1, which is 4. All of that over 2. So we have 9 plus or minus the square root of 320 over 4, which is 80. 9 plus or minus root 80, which is 9 plus or minus 4 root 5. This is x squared. So 9 plus or minus 4 root 5 is equal to x squared. But they tell us AB is greater than BC, so x is greater than 1, and therefore x squared is also greater than 1. So we have to take the positive solution to this quadratic, and we have x squared equals 9 plus 4 root 5. And we want x, not x squared. The square root of 9 plus 4 root 5, let's call it a plus b root 5. Then squaring a plus b root 5, we get a squared plus 5b squared plus 2ab root 5. So we have a squared plus 5b squared is 9, and 2ab is 4, meaning ab is 2. It's not too hard to see based on this that a is 2 and b is 1. So we have x equals a plus b root 5, which is just 2 plus root 5. Going back up to the problem, we hope that 2 plus root 5 is in our answer choices, and indeed it is. That's answer choice D, and we are done. Thank you for watching my YouTube video, and please subscribe if you would like to see more videos.